When we talk about making AI safe, what's the first thing that pops into your head? Probably checking what it says, right? Making sure the final output is okay. But what if I told you that whole approach is a dangerous dead end? Today, we're going to dig into a pretty radical new idea. What if the real key to AI safety isn't policing its final words, but certifying its initial thoughts?
And look, on the surface, checking the output makes perfect sense. Of course it does. An AI cooks up a response, and before it gets to you, some kind of filter checks it for anything nasty. If it's bad, you block it. If it's good, you let it through. It's simple, it's intuitive, and it's pretty much how a lot of systems work today.
Here's the catch, though. This simple approach has a massive, massive vulnerability. It's always playing defense. It's always one step behind. Imagine a goalie trying to block an infinite number of completely unique shots. It only takes one miss, just one, for harm to get through. So you have to ask, is there a better way? A way to get ahead of the problem?
Okay, let's really break this down. This new approach, well, it flips the entire script. Instead of reactively checking the final words, it proactively certifies the AI's thoughts. Instead of a brittle system that an adversary could trick with just a tiny change, this one is mathematically robust. And here's the real game changer. It doesn't just block bad outputs. It can actually take an unsafe proposal and guide it, repair it into something safe. But that begs the question, what exactly is an AI's thought?
Well, before an AI picks a single word to say to you, it actually generates this huge list of every possible next word, and each one has a probability score. The best way to think about it is like a giant menu of options. This entire menu, the full space of possibilities and their likelihoods, that is its thought. And that's the thing we can actually analyze for safety before a single word is ever chosen. So, this powerful new method has a name. It's called Certifiable AI Safety Theory, or CAST for short, and it's basically a mathematical framework designed to move AI safety out of that slow, leaky world of filtering outputs and into the rigorous, proactive world of certifying the entire space of possibilities.
Now, this is where it gets really cool. With CAST, safety isn't just a list of bad words. It becomes a geometric concept. Think of it like a map. The horizontal axis might measure, say, the risk of manipulative language, and the vertical axis could be the risk of leaking private data. That green box, that's our predefined safe zone. For any action to get the green light, the AI's entire probability distribution, its whole thought, has to land squarely inside that zone.
And the reason this old geometric thing works so well comes down to a key mathematical property called convexity. The source material puts it perfectly. Convexity is not aesthetic, it is the structural enabler. What does that mean in plain English? Well, a convex shape has no dents or holes in it. And that simple property is absolutely crucial because it guarantees that if something is unsafe, there's always a single closest safe point to aim for. It makes the repair process efficient and mathematically reliable every single time.
So how does this actually work in practice? Well, it's a four-step safety gate. First, the AI proposes a thought, its menu of possible actions. Second, a trusted monitor checks where that thought lands on our safety map. Third, if it's inside the safe zone, boom, a certificate is issued almost instantly. And fourth, the action is released. But, and this is the important part, if it's not safe, the system can either repair it or just fall back to a pre-approved safe response.
And this visual just illustrates that repair process perfectly. You see that red cross? That's an unsafe proposal, sitting outside the green safe zone. Now, instead of just blocking it and saying nope, CAST performs what's called a projection to safety. See that blue arrow? It mathematically calculates the shortest, most efficient path to the nearest safe point on the edge of that zone and just nudges the AI's proposal there. So it's not a bouncer at a club, it's more like a helpful guide.
Okay, all of this sounds incredibly powerful, right? But the whole system hinges on one really big question. If we've got this monitor acting as a gatekeeper, how can we be absolutely 100% sure that we can trust it, especially if a really smart AI might try to trick it?
Well, the answer isn't just trust us. It lies in a super strict set of rules called the Monitor Capability Contract. This is a hardcore engineering specification. For example, state-freeze semantics means the AI's thought is totally frozen during inspection. It can't change its mind halfway through to try and fool the check. And logits access is critical. It guarantees the monitor can see the AI's entire menu of options, not just the one choice it wants to show you. It's a system built for verification with a permanent, unchangeable record of every single decision.
So we can check a single step. That's great. But what about the long run? A system could be perfectly safe on every individual decision, but still cause a ton of harm through the accumulation of thousands of tiny, seemingly harmless risks. You know, the classic death by 1,000 cuts. How does CAST stop that from happening?
The solution is actually pretty brilliant. You have to think like an accountant. CAST is given a total risk budget for an entire task. It then intelligently allocates a tiny fraction of that budget to each and every decision it makes. As you can see here, there are different ways to spend it. You could spend the budget evenly over time, that's the flat, uniform line, or you could decide to spend more of your risk budget on more critical early steps, which is what those other curves show. The main point is, by making sure the total spend never goes over budget, CAST guarantees safety, not just for one step, but for the entire journey.
So when you put all these pieces together, you've got certifying thoughts, geometric safe zones, this projection to safety idea, and risk budgets, you end up with something that's more than just a new technique. This is a fundamentally new paradigm for how we engineer AI safety. It's a massive shift from playing defense to actively shaping an AI's behavior before it even acts.
So let's just put it all together one last time. What is the fundamental shift we're talking about here? We are moving from a reactive system that acts after the fact to a proactive one that acts in real time. We stop just blocking or allowing, and we start certifying, repairing, or replacing. We're trading a brittle, fragile guarantee for one that is mathematically sound and robust. The end result is huge. We go from just blocking specific bad words to actually guaranteeing safe behavior.
And here it is. This is the ultimate payoff. In the world of finance, tail risk is that small chance of a catastrophic, completely unpredictable event. For AI, that's basically the nightmare scenario. What CAST does is it takes that terrifying, unbounded tail risk and converts it into something manageable, a quantified, auditable, and residual risk. It's the difference between hoping a powerful system behaves itself and having a mathematical receipt that proves it will stay within the bounds we set for it.
And that leaves us with one final and really profound question. For maybe the first time, we have a mathematical toolkit that can rigorously enforce any safety rule we can define in this geometric way. So the challenge is no longer just a technical one of how to enforce the rules. The challenge now becomes a societal one. What rules should we write? What values do we want to embed at the very core of our AI systems? That's the conversation that CAST finally allows us to have.